Good morning. Thank you for watching my videos here. Thanks for tuning in to my channel. So today's video is part 18. You can find it in my playlist entitled PIC10F200. And in the last two videos, I've been developing some code to control a shift register, specifically the serial in parallel out 74HC595 shift register. Not only does this video pick up where these last two videos left off, it actually builds upon two videos I made in preparation for controlling this particular shift register with a PIC10F200 microcontroller. I built a popsicle stick module where I have debounced signals controlled by push buttons, and then I manually manipulate the pins on the shift register with my fingers. So forgive me if I keep repeating everything as an introduction at the beginning of these videos, but that's just in case somebody is jumping in and watching these videos and not understanding what I'm even talking about. Alright. So my last video, I successfully got the PIC10F200 counting and displaying that information on a shift register. So the PIC10F200 is actually doing two things now. It's counting and it's outputting that data on a serial line on a shift register. That's pretty impressive when you consider that the PIC10F200 only has 6 pins. It has 8 pins, but 2 are unused. And it has 6 pins, and only 4 of those 6 pins are GPIO pins. And not only that, one pin, GP3, is input only, and that leaves 3 other pins as output. So I would say I am using the PIC10F200 pretty efficiently, and I haven't quite reached the limit of program lines of code yet either. I don't know when that's going to happen. In my previous video, I tried to clean things up and reduce the lines of code with mixed success. Now, I hinted at it in my previous videos that I would like to control this setup potentially with a 555 timer as an input. And because I'm running out of pins and because GP3 is input only, I'd like to take GP3 here and actually use it as an input pin. Currently I am using it as the mClear pin, so it can't be helped. I'm going to have to turn the mClear pin off. Now, I'm a student still, and if I'm showing this to you, it's not from the position of an expert. I'm learning much of this for the first time. And one of the things that I've recently been working on learning are, well, two things: interrupts and timers, particularly with the 18F chips. And I know that the PIC10F200 has a timer. And hold on. Well, not the device reset timer, not the watchdog timer, not those, but it has an 8-bit timer. It has one of them. It has no comparators. I just learned that now. If we want to look at that, the table of contents says that we can go to part 6 of the data sheet. It's talking about the timers. Timer. Here's the register associated with timers, that option register. And I guess TMR0 is reserved for the clocking of the 8 bits. So this is page 24 of the data sheet. There should be a link for that below. Here's the program memory map. So here's the program counter. The stack, I guess it's a 2-level stack. A reset vector. Well, anyway, I looked up interrupt on the Chrome browser word search to see if I could find it in this data sheet, and I don't get any results. So I can't be sure, but I don't think there's capability to have interrupts. I stand to be corrected. So I, once again, am long-winded, but I'm just explaining things as I see it, just being very open to let you know how I'm going about this. You might know more than I do, very possibly. Although if you know more, why are you looking at the 10F200? You should be doing something really amazing with some of the other chips. There is a reason I mentioned all of that, and that's because there's this concept, maybe you know, that there's a difference between polling in your code, waiting for something to happen, and using an interrupt. So for instance, if you have a code with a lot of delays, as mine happens to have, then you can't implement like a bit test until a certain subroutine or block of code has iterated through. And say you have like an input pin that you're bit testing, but the code is actually iterating through, and maybe that takes several seconds. You can keep pushing that button that you've set up as an input pin, and the microcontroller won't respond to it because it's busy iterating through a lengthy block of code with potentially long delay routines. So that's why an interrupt can be useful, because it interrupts whatever the CPU is doing, and it goes to an interrupt vector, if that's the right word. So I could be wrong, and I stand to be corrected as I work through this into the future, but I don't see a way of putting an interrupt into this program, so it'll have to be polling. So there was a guy on YouTube who made a really great video on the BTFSC instruction. So I went and watched. Oh wait, that's me. I made this video, and it's video 12 in my PIC10F200 playlist, and I just watched it as a refresher as to how to code with BTFSC. Come on, look at me go. So I borrowed that code, and I'll have to modify it, but I'll paste it in here. And I want to bit test GP3, which I already have set up as an input. I guess I want this loop to hang here until GP3 gets a high, gets set. So I want it to skip over something, and I want it to loop back to loop. And all this stuff I can delete, and I'm still working it through, but I think I'll have it go to this bit tester. So it'll bit test file GP3. What does the F stand for? Bit test. Oh well, it'll bit test GP3 and skip if it's clear. So if it's clear and unpressed, it'll just skip this second line. It'll skip and it'll go to this line, and it'll just loop back, continuing to iterate and skipping over this line until GP3 is set. So skip this line if GP3 is clear. If GP3 is set, it won't skip the next line. It will go to bit tester, which will run through its thing, and eventually when it's done, it'll go back to the loop. So I guess in theory this works. I'll clean and build. Okay, that worked. Now I will upload. And that worked. My next step is to go to my PIC10F200 board setup.
Okay, you might laugh. This isn't working correctly. I have GP3. Just trust me, it's hooked up to GP3, hooked up to the 555 timer. And so long as the 555 timer is high, it's iterating through the code. But that's not exactly how I want it to work. So maybe I need a delay routine after GP3 input pin is set high.
So I've done this previously. I'm not sure how to do it today. This delay routine is simply too quick, so maybe I need another one. So I think I want a longer delay. Okay, so that didn't work. Oh, hey guys, this is several hours later, and I'm a little tired now. I've been working on this for a long time. So what was happening is I had GP3 as an input, and a 555 timer was sending in its highs and lows, 50% duty cycle into GP3, and because the microcontroller iterates through code so quickly. When the 555 timer was sending in a high signal, the code would iterate and break into this bit tester subroutine. But by the time it ran through the bit tester routine, it came back up to the top of the code, and the 555 timer signal was still high because the microcontroller operates so fast. So what I needed to do was, before allowing the MCU to break back into the loop and testing the state of GP3, I had to make sure that the signal was low again, which is why I created a separate subroutine called release. And this will bit test the file skip if set. So it'll skip the next line of code if the signal is still a high or if it's still set on GP3. And only once GP3 goes low again, it won't skip. It'll just go to the next line, which is go to and loop. And it'll start back in the loop here again, testing for when GP3 receives a high signal again, and then it just iterates through the code. But I did all kinds of crazy things. As you can see here, this is a total waste of code. I just couldn't figure out a relatively simple problem. So thanks for watching. I hope that's helpful. Have a good day.
Hi guys. Okay, this is the video after I got my code to work. So yes, the trick was really to have a release subroutine that wouldn't allow the MCU to go back into the loop until it was at a low setting again. Because originally what was happening is, as the 555 timer was high and sending a high signal into GP3, the microcontroller iterates through code so quickly that by the time it goes to the top of the code again, into the main loop, the signal is still high. So I couldn't allow code iteration back into the main loop until the code had reached a GP3 input low state again. So that's the whole purpose of that release subroutine. I don't know if I've explained it well enough, but yeah, works pretty well. I can't remember if I experienced this problem before using my 18F. I don't know. Anyway, thanks for watching.